and welcome to my write-up of K2 Middle Camp from TryHackMe. K2 Middle Camp is the second installment in a series of 3 machines. This means we use information gathered from the other machines to aid in exploitation and the takeover of the other machines. This machine starts with using previously found information such as usernames and passwords to find a valid Active Directory domain account. From there, we can find notes in that user's home directory that point us to the key space of another user's password. From there, we can generate a script to find all possible passwords and then brute force against Kerberos to find the second valid Active Directory account. From there, this user has access, is part of a group that has generic all on another user. The user we have control over is part of the backup operators, meaning we can copy the nts.dit file and the system hive to get the Active Directory NTLM hashes. So first thing we're going to do is start with an nmap scan. So nmap-scv-vv-t5, and we want this. So all this means is we're enumerating the scripts. So we want to run a script enumeration, meaning that it'll run the common scripts against the services. So it will look for common vulnerabilities or do a little bit of poking, such as is there a .git file on the web server, or is it running a vulnerable HTTP version, stuff like that. -v will output the versions, so stuff like the FTP version, SSH version, and VVV is the max verbosity, so it will output the most results. Instead of holding back information, it will pump out a lot of information. And T5 for the max amount of threads this nmap can run. Keep in mind that this command can miss stuff, but I like using it for the sake of speed. But it can miss ports and will alert if anyone's listening on a SOC or watching the traffic, because it will be very fast. You can see it looks like a valid domain controller. That looks to be like RDP, SMB, DNS, and Kerberos. Seems to be a valid domain controller, and we have Writeup here. In just a second, it will output an SSL certificate. You can see here, SSL certificate running on the RDP service that discloses the common name of this server, which is k2server.k2.tryhackme, and it shows we're part of the k2.tryhackme domain. We can edit this in the etc host file. The etc host file is essentially the first place a computer looks to resolve domain names before it connects out to external DNS servers, and we've already added it here. So 10.48.170.220 to k2server.tryhackme. Okay. First thing I did was attempt for null authentication, or can we connect to SMB, RPC, LDAP without having to provide credentials, meaning we could potentially look for passwords in the description, use Bloodhound, RPC, we could be able to enumerate more users and user descriptions. SMB could be information interesting in the shares. However, we don't have access to a guest account or null authentication, so we can't do this. Next thing I want to do, or the next thing I do in Active Directory when I can't find anything is, and don't have valid domain credentials, is try and get valid domain credentials. Keep in mind, this is the second installment in a series of 3, so we have a list of usernames and passwords that we found from the previous machine. We have them here. So these passwords are passwords we dumped from the database. I think this is a password from the database connection, and this is a password from a user's history file. And then we have a list of all users we found, and we included administrator and guest just in case we have valid credentials for these users. If the guest account does exist, it'll just be no password, but I'm just including it here to check if the guest account is actually up. And Active Directory normally has a naming convention of, like, you know, j.bold or james.b or, you know, james.bold. So this is what like your standard Active Directory naming convention would look like in terms of CTFs, or just in general. Seems to be the kind of consensus around how you would name With this in mind, we can transform the users we found on the other system into potentially valid Active Directory names. There is tools that'll do this automatically. However, I've just done this manually because there's only like 3 or 4 users. And I will show you here. We can see here James B, J Bold, James Bold, Rose B, R Bud, and Rosebud. We got these last names from the previous machine, and these were disclosed in the description segment of the Etsy password file. We can use the tool Kerberoot, which will contact Kerberos to look for valid domain users. And this works because Kerberos will return different results when requested for a valid user and not requested for a valid user. And we can use this to our advantage to test for valid domain accounts. And we will do just that. So Kerberoot user enum function, we're supplying our user list. We're supplying the domain, which is k2.tryhackme, and the domain controller we want to attempt to query Kerberos on. And this will run and outputs this result. So it's kind of our hypothesis we were testing, where we just do like try and mutate into standard domain credentials, standard domain user kind of format. And we have administrator jbold and rbud. We do not have the guest user, hinting that or telling that it's not valid on the domain. So that's a good step in improving overall security. However, there's a lot of mishaps that an administrator took in this domain. But that's a decent step in protecting security. And what we're going to do now is brute force Kerberos, or not Kerberos, we're going to brute force a service to try and see if any of our previously gathered passwords stick to these usernames. Before I do this, or before you do this in a real engagement, you want to check, or you want to make sure you know the password logout, what's it called? It's on the tip of my tongue, but you want to make sure you're not going to lock out accounts. Yeah, account lockout policies. So potentially if you miss 5 passwords, it'll lock out the account. That's not going to be good in any engagement, because first, you'll get detected. Second, you'll shut down accounts and potentially violate some sort of agreement you have with whoever you're pen testing against. You could request this information directly from the company you're pen testing if they want to disclose it, or you could use some information gathering if you have access to LDAP, etc. Potentially RPC could disclose account lockouts. Or you may be able to go to RDP and do some authentication, and it may spit out saying, oh, you only have 4 more tries remaining, stuff like that. But you just want to make sure you don't lock out any accounts. But we don't have to worry about this because this is a CTF environment. But let's just do just that. So we'll use netexec to test against LDAP here. And netexec LDAP, we're testing against the domain controller. And we're just going to use the user word list. And we're going to supply the passwords and continue on success. If we don't supply continue on success, if it hits 1 valid credential, it'll stop testing the rest. However, we've supplied this, so if it hits a successful credentials, it'll keep continuing. And we're just going to have to wait for this to finish. Couldn't be more than a minute, because our word list is quite short. Maybe should have made a word list with all the valid user accounts, but definitely shouldn't be much longer. Yeah, Pikachu. That's the third last. And we had a successful hit. So rbud and then this password. This password was actually gathered from the history file of the Rosebud user on the previous Linux machine. If you just followed enumeration steps and probed into the user home directory, you'd find that the bash history wasn't actually getting piped to dev null, so the history was being wrote. And it actually contains information. So that's good. We'll just create a valid user thing here. r.bud, oops, bud, j.bold, administrator now we have valid domain credentials, so we can start our enumeration of the domain. So we can run Bloodhound, tester for anything in SMB, RPC. What I'd like to do is find other users on the machine, so we will use LDAP for this purpose. We can use netexec to query LDAP. I like netexec because it provides a little bit of abstraction from utilizing the LDAP protocol. You could use commands such as LDAP search, but it's a little annoying to kind of get the whole well, it can be annoying to get the whole syntax right with supplying the common names and, you know, like the CN, C2, CN, THM kind of thing. And then netexec just provides that nice layer of abstraction and provides utilities to automatically do queries for us for stuff like user accounts. So we'll just do kdb server and we'll supply the user of r.bud and the password of this here. If it's in double quotes, it will actually interpret this exclamation point into the bash command getting executed, and it will actually interpret this. But if we put it in single quotes, it will just ignore it. It's the same as doing a back. What's it called? Back something. Besides the point. I actually want to do this here. We'll just supply the -- users flag, and this will just return all users. And we have J Smith, Kerberos ticket running ticket account, guest account. Let's see here. I thought it was disabled. We'll rerun this. Maybe it. Last password set never. It's testing. Yeah, I think it's still disabled. J Smith is the only user that we don't currently know. So we'll just add it to valid. J.Smith. So once I get a new user, I like to just retest credentials to see if our new user maybe sticks to some of our passwords. However, this isn't the case, but during my partaking in this machine the first time, that's the step I took. This step in this lab is to actually connect to this machine via like WinRM or RDP, and then we can find some interesting information in this user's home directory. For simplicity's sake, I will use evil WinRM. I've got the syntax already. Pod, P, and just get the password here. And evil WinRM is just going to use the WinRM protocol to authenticate to this machine. What I like to do first is obviously run whoami-all to gain kind of an idea of the context we are in this system. But after that, I always go back to the users directory and see if we have access to any interesting files. And we can do that with tree So this is just going to recursively list all directories, and we only have access to the bud user, and we have some interesting things in the documents section. So we'll just go to bud documents. And I spelled that wrong, damn it. It may take a second because WinRM's kind of laggy. It's taking a while. Okay, let's air it out finally. Ugh, spammed enter. Okay, so let's read this note. Done. So done. Note was sent to James. He has informed me that they kept the base password the same. They just added 2 more characters to meet the criteria. And James' password meets the criteria, and pending, give James remote access. So James has changed his password, but he's kept the base password the same and has added 2 more characters to meet the criteria. So he's only added 2 more things on his base password. If we can find out his base password, we could just create a list of passwords just with all different combinations of 2 additional characters, and we can try and brute force. Type note to James. Hello James, your password RockU was found to contain only alphabetical letters. So his base password RockU, from the information gathered from above, he's only added 2 characters to RockU. And the password policy states it must include a special character and a number. So his password meets the criteria and it adds 2 characters, meaning that one of those characters had to be a special character and one of them had to be a number between 0 and 9. And this is a little funny, must include at least a number between the range of 0 and 999. That's a little silly because a number can only go 0 to 9. Yeah. But we know that he has to have added a single number and a single character to the RockU, and that is what we're working with. Once I found this out, the key space was quite small. I created a short Python script that would just make all the valid passwords, and we have it here. I just called it pass mutilate. And we just essentially open the genwordlist.txt and append all numbers through 0 and 10 to the base, and all punctuation from the string library. So everything from ats, exclamation points, brackets, quotes, and we just did it at the start and at the end. And then we did this one with applying the punctuation first and the number, and then we did that at the start and the end. This one was applying the number first and the punctuation. Don't know why I did it in 2 for loops. We could just do it in 1, but I guess I wasn't thinking. Let's run this script and cat pass gen word list, and you can see here it's just everything mutilated. RockU. We can run netexec again to test for valid credentials for the JBold user, which is the user we had these password hints for. For the sake of time, I'm just going to not avoid that, but essentially the password is #8RockU, and we're just going to get our word list here and grep, let's see here, -8, oops, and hashtag 8rockyou is included in our generated word list, and this is the successful password. So we'll just vim pass and put this password in here. And let's test these passwords against LDAP. Use valid sp pass continue success. And we're just going to test to see if the password sticks. We get the rbold user, we already know this password. And we get the jbold password of hashtag 8rockyou. Now we have access to this user. We can get the flag from this user's home directory. Actually, it may be from the backup operators user, but we can get we will get the flags eventually. Now I ran Bloodhound. Well, I actually didn't run Bloodhound, surprisingly. My Bloodhound wasn't working because I forgot the password, so I'm just going to have to reset my VM and reinstall. But since I didn't have Bloodhound available, I was looking for... First on, I went connected... we couldn't connect remotely. Meaning we couldn't look for local privilege escalation, such as the scheduled tasks or registry vulnerabilities, auto runs, stuff like that. So we're limited to purely the Active Directory path of privilege escalation. And what I did was just queried LDAP to find the groups for this user. So we'll just do netexec again, LDAP. Doesn't have to be the jbold user. It just has to be a valid user because we can query anyway. Oops. Do that. Query. And we want to query object class equals user, and we get rerun it, so it's a line wrap. And the jbold user here. Jbold user is up here, so we get all this information. And what I was mainly interested in was the members, or the group memberships. And you can see here it's part of a non-standard group, which is IT Staff 1. This is not standard in a domain controller, or in Active Directory. Sorry, not domain controller. This is a standard group. This is custom. I also noticed that the Jack Smith user was part of the backup operators, so we could back up all system files regardless of the permissions if we're part of this group. So I was aiming for this user, and I noticed this IT staff group. And what I did next was I essentially used the Python Bloodhound ingester. So Bloodhound Python... what's the password? Dash -u, and the user jbold. Oops, needs an IP here. Just apply the IP. Get it up here. And it's just gonna query LDAP and output all the Bloodhound JSON files. So it's just gonna output JSON files that Bloodhound then uses and interprets. However, this information that Bloodhound is using to interpret, we can actually read it. They're just stored in JSON files, and it's just structured data of all the users and all the groups. And then Bloodhound will analyze that and then forge connections. 7 users, 54 groups, 2 group policy objects, 19 containers. What I did was open this up in a web application, Python. So what we're going to do is just start a Python server on this directory, and then we're just going to navigate to it here. And computers, containers, groups, users. And what we are interested in is any privileges our group IT staff 1 has over other users. And this is the JSON data for the JSmith user here. And then these are the ACEs, or access control entries for that user. So this is the groups that have privileges over this user. So this isn't the user's privileges. These are the privileges that other objects have over this user. So you can see here, the security ID of principal type group owns this user, and the SID, security identifier of a group, has generic right on this user. Some have generic all, some have extended rights, etc. So these are just listing all the permissions that something has over this user. And we want to know the security identifier of the, what's it called, IT stuff here. So we want to find the security identifier of this, and then use the security identifier to look for any privileges it has on other users. And since there's only one other user in this domain, I'm just going to look for JSmith. I'm just going to go to 127.0.1, 8000, and we're going to go to the groups.json, and we're going to search for it's called IT staff 1. Okay. Scenes up the top here is the JSON data for the object, the group object IT staff, and we have the SID up here. We're just going to copy that and see where this SID is referenced in this JSON file. We're just going to apply this SID and see where this is applied. So this SID owns something. Actually, it's not the complete SID, I don't think. I think we're looking for this. Looking for this. The domain SID is the security identifier of the domain, not the full SID of this object. The 116 is appended to the domain SID. We'll search for this instead. You can see here. So this SID of our group has generic all over something, and this something is JSmith. So that's the path I used to find out that our group has generic all over JSmith, and I did so without Bloodhound. So it's interesting to know how the relationship actually works, and the access control entries and the access control list that Bloodhound interprets. So when you get situations where you can't run bloodhounds, you can figure out solutions. So we know our group IT Staff 1 has generic all over this JSmith user, meaning we can edit pretty much anything on this user. We can change a password. Don't know if we can change the name. I think we can change the name. We can change all sorts of things, add it to groups, take it away from groups, etc. We can use RPC to change this user's password to whatever we want, and that's what we're going to do. So we're just going to use the RPC command here. So net RPC, the password. So this means we're going to use RPC to change the password, and we're going to change the password on the JSmith user. And the user we're going to use to authenticate this action is jbold at k2.tryhackme with the password #8rockU. And we're going to have to enter the new password for JSmith. We're just going to enter password 123 question mark with a capital P. And this sets. The reason why we added password 123 question mark with a capital P is to abide by the password requirements set for this domain, which I assume are enforced, but were disclosed in the previous note. And this means we have the password for JSmith, which is password 123 question mark, and we can successfully authenticate as this user. So let's just double check. Netcat netexec smb k2 server k2.tryhackme -u smith -p password question mark. Yep, let's test. And yes, valid domain user. This user is a backup operator. Backup operators have the special privilege of being able to ignore all permissions on a file object with the purpose of being able to back up that file. Meaning that important files such as the system and samhive, as well as the entities.dit, can be extracted and then we can gain information from it. So the samhive, or I forgot what SAM stands for, but security application management, it essentially just stores in the context we want, it just stores local hashes of passwords. And the system will use this samhive to check authentication. And the last 15 authentications temps, I think that value can be changed from domain to domain, but the last 15 authentication attempts are stored in the samhive. And however, we don't actually want this. So I was saying how the samhive is local. This stores local hashes used for local authentication, and I guess you can have Active Directory hashes in there if an Active Directory user was to sign on to that account or sign on to that machine. However, the entities.dit file stores the Active Directory hashes. This file is stored on the domain controller, and it stores all the NTLM hashes for all the user accounts on the domain, and we want that. So we want the system hive, and we want the entities.dit hive off the machine, and we can do so with our backup operator privileges. The system hive stores the boot key, which is needed to decrypt the NTLS file and decrypt the SAM hive. So that's what we're going to do. We're going to dump the entities.dit and the system hive. And we can do so. What we're going to do is connect via evil WinRM. And we're going to back up these files using the inbuilt evil WinRM download function. We know this JSmith user can actually WinRM and RDP because it was part of the group. we can't get it here, but it was part of the remote management group, so it has the permissions to do this action. What we can do is just use the reg save command to save the system, the registry hive to our home directory. And we're just going to download this. And this will just save it on our local machine. This is going to take a second. So I will be back. On second hand, I guess while we wait for this file to download, we can explain the next steps we're going to take. So we want to download the nts.dit file. However, the nts.dit file is constantly under, I guess, read, or it's constantly open, meaning that we can't actually back up without doing some certain actions because this file is being used, and it'll just cause some issues. It won't let you download it directly using like reg save or whatever, which is only used for saving registries, but we can't just copy over the file because it won't let us. So what we have to do is create another drive called the X drive, and we're going to set that X drive to be a shadow of the C drive volume, meaning that we can move files from the C drive onto this shadow drive, and we can create this this extra drive called X drive with the disk shadow. So what we're going to do here is create a file called config.dsh, and this is just a config file that disk shadow will use to create this this new shadow drive. So let's explain this. So set metadata C equals exfil of fake cabs. This is just where we are going to write the metadata of this drive, this new drive to. So it has to be a valid directory. We're going to set the context persistent no writers. We're going to add the volume C drive alias system shadows, and then create that, and then we're going to expose the system volume shadow as X. And you'll notice here we've got the hashtags at the end. This is to confirm there's a space. So after each of these lines, there has to be a space. However, you can't see there's a space unless there's a hash afterwards. So that's just there to prevent confusion and check there's spaces before this command's being run. Otherwise, it'll just error out. So we're going to upload this to the machine. We'll do that again with evil winrm. And the download's successful. So we're just going to upload. Go full screen, so it's not. This file's quite small, so it should just be a second. Okay, 200 bytes copy, sweet. Evil winrm's pretty laggy. Haven't been able to fix this issue for a while. I've reinstalled everything. Although I've seen examples of people using like a Python version, and it seems to be alright. But yeah, I've been having issues with winrm. Let's just close this down and open this window up here. And we have config.dsh stored. What we're going to do now is run the following command. Disk shadow-s and config.dsh. However, first we have to expose the C drive exfil directory so we can properly write the metadata file. Lag is unbearable. just going to run the command -shadow-sconfig.sh, and it's exposed the X drive. And then we're going to use the tool robocopy to copy over the Windows NTDS file to our new shadow copy of X. So it's going to copy C drive ntds.dit to X drive Windows NTDS. Okay, that works. And then we're going to download ntds.dit. And this will take maybe 5 minutes due to the speeds of WinRM. But I will be back. Okay, after maybe 5 minutes, I've downloaded this, and we should have both the ntds.dit and the system hive. And we can just decrypt this with the impacket secrets dump tool. And this will just get the boot key from the system hive, and we'll decrypt the ntds.dit. And we're just going to specify we're doing it locally, and we're not remotely accessing this to decrypt. I think it would use such maybe RPC to enact this action, but we're doing it locally because we have the files and we have all the hashes here. So this is all Active Directory domain hashes. If we were to decrypt the SAM hive, we may not get some of these users. We definitely won't get the Kerberos ticket, the Kerberos NTLM hashes. Yeah, and it found the system boot key, which was in the system hive, and guessed Kerberos TRNA service, RBAR, JBAL, JSmith. We have the NTLM hashes. All we care about is the LM hash, or the NT hash, sorry, of the administrator, and we'll use this to authenticate. So we'll just use impacket here again to psexec, and psexec is essentially using SMB to write a file, and then it's calling a scheduled task to call a program which runs this file. So it's just going to upload a malicious file and here, and then run it with a scheduled task. Sometimes it doesn't work. Don't know why. But when it doesn't work, I just use WMI-exec, which is essentially doing a similar thing, but it's using the Windows management interface, I think, which allows you to do remote actions on another machine. It's creating a service, not a scheduled task. Similar, but different. Doesn't seem to be working, so we'll just run WMI-exec. Maybe rerunning it would fix some things, but for simplicity's sake, I'll just use WMI-exec. Okay, and it works. Sweet. We should be NT authority system, which is the highest level. Oh, no, we're administrator. I think WMI-exec is different than psexec in the way that psexec will have our privileges to NT authority system. WMI-exec seems to have the privileges of a user. I think this is something to do with the service being called. This seems to be a little quicker. Let's see if this works. Yeah, after maybe a minute, this still hasn't worked. Not exactly sure why again, but yeah, we'll just use WMI-exec again. And yeah, that is the machine done. We're the administrator user. We have full domain admin privileges, and we can do whatever we want. Since this is the second installment in the 3 machines, I conducted some information gathering. So I used Mimikatz to dump the hashes, and then realized that I already had all the hashes, so that was pointless. But I tried to crack the hashes to gain passwords I may be able to use for the next system. However, none cracked. However, keeping note of the hashes will aid in the will aid in the initial contact with the machine, with the third machine, which is also a domain controller. Overall, I like this machine. I really like the fact that it uses information from the other machine. This means you have to think, like password reuse. How would they potentially change their usernames? How a user may reuse a password on this system. You have to think in a more attacker-centric mindset, which helps for real-world engagements, I guess. Sometimes the whole context of the network can be lost in single machine systems, where you don't really have to worry about storing found usernames, storing found passwords. But this is nice. However, thank you guys for watching. See ya.